There's an increasing need to deliver better and faster services, and with that, there's a huge demand to access, create, use, and share data from any device. In our webinar today, we have Maulik and Shah to talk about IoT and embedded QA. Maulik is a senior technical lead at eInfochips, an Arrow company. He has more than 14 years of experience in software QA automation and more than 11 years of experience in designing, architecting, and implementing complex framework solutions for IoT products automation. He's an expert in automation using Python, Pytest, Selenium, and Appium on Linux, Mac, and Windows platforms.
Hi everyone, wishing you happy Global Testers Day. I would like to thank you Touch for providing this opportunity to share my knowledge and experience on this very interesting topic about embedded testing and IoT. I am Maulik Shah from eInfochips. I will be talking about what is embedded testing, what is IoT, types of testing for IoT, tools for IoT testing, how you can automate the IoT devices, how you can set up your end-to-end validation framework using lot of other tools for IoT testing. So let's talk what is IoT testing or what is embedded testing or what is embedded. So first question which comes to your mind is what is embedded system or what is embedded computers. So embedded system are nothing but they are similar to the computers which we are using. That is also coming out with the combination of hardware and software. Embedded system nowadays present in all electronic devices which we are using. For an example, from microwave oven to mobile phones, from a spaceship to drones, you can consider digital cameras, temperature measurement system, applications such as refrigerator, washing machine, microwave ovens, aircraft control, missile defense system. Those all are embedded devices or embedded system. As a QA, we this is one of the challenging and interesting area to know about how you can do a embedded testing. Same as any other software testing, you can do a embedded testing is nothing but you can do a functional and non-functional testing of the hardware and software for the embedded system which is developed for a customer or developed as a product. The product should obviously defect free. The primary goal of embedded system testing is nothing but that whether the product or a hardware and a software is meeting to the client requirement or not. There are two parts into the embedded system. One is hardware and one is software. First, you need to understand that how the hardware is working and how the software is working, and then how you can validate or how you can do a embedded related testing. So first step which comes to your mind is that how you will do the testing of embedded device. So first part is nothing but a hardware testing. For hardware testing, you need to understand that how the embedded system is fetching, decoding, and executing the instructions. You need to understand how the data is transmitted through the system and how the functions are controlling to each other. You need to understand the relationship between data transmission, receiving the frequency, clock speed, as well as their coordination. You also need to understand the function address, data, control bus connection. You need to understand how the data and instructions are stored into the hardware memory. Once you understand that, you need to understand that how the hardware and software are doing handshaking with each other. You need to validate the performance of your software on the hardware. You need to validate the connectivity, communication, and memory uses of your software on the hardware. You need to validate the data transmission. You also need to validate the different functionality which are built for of your software. For an example, you have any camera, so you will validate that if you have configured a streaming which should have the 1080p pixel, then you will validate that whether the streaming which are been configured on the software, whether the same are coming from hardware or not. Now let's talk about what is IoT. Now you will feel that like from embedded system, why we are moving to IoT. IoT is nothing but any embedded device which needs to communicate with any ecosystem to transmit the data. It needs to be connected via different protocols such as Wi-Fi, 5G, LoRa, RF, Zigbee, Z-Wave, and when they are transferring data and establishing a connection, those embedded devices are becoming IoT devices or IoT. IoT is nothing but Internet of Things. Another question which come to your mind is that how you will consider or what are the example of IoT devices. So the example which we have seen, a camera. Now the camera which is communicating right now as a local entity, if you install those camera, if you consider your local CCTV camera which you are accessing from the mobile, so that become an IoT device for you. If nowadays the refrigerator or a washing machine or microwaves are coming having internet connection established, your air conditioner, you can start or stop your air condition even if you are at a remote location via Wi-Fi connectivity. So when your air conditioner we connect with the internet, that became an IoT device. If you have set up a temperature measurement system into your home, and if any alarm is getting triggered, the alarm which get triggered via internet connectivity and giving your notification on your mobile, that is IoT device. If you have refrigerator or a washing machine, and if you want to start a washing machine when you are away, or if you want to start a dishwasher when you are away, those are becoming example of IoT devices. The mobile phones which you are operating remotely and accessing certain activity, or using mobile phone if you are accessing certain devices from home or from remote location, those all embedded devices are becoming an IoT devices. Now let's talk about how you can do a embedded or IoT device testing. We learn or we all are aware about what is OSI layer when we studied during our engineering or maybe your MC or any other qualification. The devices or embedded devices are doing a communication or setting up an establishment on this interface only. For an example, let's talk about application layer. So the hardware which is on which your software is installed, those hardware and their functional testing are coming out as a part of hardware functional testing, and those are a part of application layer where the application or the website which you have developed needs to be connected and establish a connection and validate that. So that entire part is called as application layer. You can do a compatibility testing, usability testing, interface testing for those IoT devices. For the software which is installed on those hardware, you need to do a API testing, user experience testing, or localization testing. Now let's talk about a service layer. Service layer is nothing but where you will do a compatibility testing or a functional testing, and sometimes you can also do the API testing. You can use Postman or any other tool for validating the API request and response of your devices. Now let's talk about IoT gateway and network layer. Now, what is IoT? IoT is nothing but a device which is connected. So when it is connected, the network level of compatibility and the connectivity, those are the testing types which you can perform. You can also do the data transmitter testing for your IoT devices. about software layer, you can validate the functional testing, upgrade testing, security testing, stress testing, load testing, and end-to-end validation. Now, what is upgrade testing? For an example, Google has pushed new features, or Google has created new feature, and now they want to give that update on all the Android users. So what they will do, they will upload that particular feature on one particular server, and then those users who are having compatible version, that will have the update on their system or on their mobile. That is called as a upgrade testing. For an example, you and that terminology is called as a firmware testing as well. So you can consider upgrade testing or a firmware testing as a part of software testing. Tools which you can use for embedded testing or IoT testing. Now for embedded testing or IoT testing, you need to do a two level of testing. One called as hardware testing, one called as a software testing. Hardware testing, where you will need to use specific tools to validate a specific functionalities. Based on the functionality which are developed about your product, you need to perform hardware testing. If your device having platform code which you need to validate, so you can use the JTAG dongle, which will help you to debug the target platform code, and which will show you the variable response and other things. If you want to validate the timestamp glitch or a power supply related issue or signal integrity related issue, then you can use digital storage oscilloscope. If you want to emulate your transmitter and receiver, you can use software defined ratio tool. Now, when we talk about IoT system, there is a one important aspect or one important testing which you need to perform, which is called as network protocol testing, which is nothing but whether whatever data has been transmitted from your software to your hardware, whether that reach to the same state. Have you observed any data loss? Have you observed any packet loss? So those all has been happened at a network layer. So there is a tool which called as Wireshark, which help you to do your network protocol level of analyzing. You can also do TCP dump using packet for packet analyzing. There are, as we talk about IoT, there is one important aspect which now coming into the picture is security testing or vulnerability testing. So there is one tool which is wisely used, which called as Sodan, which can help, which can be used to find the vulnerability testing of your embedded or IoT devices. Now let's talk about automation of these all IoT devices. So let's assume that you need to automate a street light. The street light is connected to the 5G internet. The device is sending a data to your server on every 1 minute, that whether that device is connected and on or off. Whatever state is into, that will send the status to your server. The device is getting turned on and off based on the sunrise and sunset time which are configured on the server. If you want to automate this entire product, you need to consider that the website where your application is being hosted or which is transmitting or sending and receiving the data, you can do a Selenium and Python based automation. If you want to do a device based validation, you can connect your device using your one of the system and validate that whatever data are getting transmitted from device to server are right or wrong. You can validate the network layer using Wireshark. You can validate the API based request response. You can also do the packet transmission related validation. You can also connect using Python library and do a device testing. Now let's talk about another example. you need to automate any audio device. The audio device is connected to the system via serial cable. The test case is developed using Python to communicate with the audio device, and the test case is validating that if you are changing a volume of your audio device from 100 to 80, whether that is getting changed on the device as well as on the mobile application or not. So you will develop a test case which will validate on the mobile device using Appium tool that whether the volume value, what is the volume value of your mobile device or your application. You will do a device automation using interface command and Python library and validate that what is the value right now on the device. Once you will develop these test cases, now let's assume that you want to do a end-to-end validation of this device, and that too on a automatic way which will trigger and validate as an continuous integration and validation environment. So let's talk about the integration of this end-to-end validation environment. For an example, the company has given the new firmware or a new upgrade about the audio device which you are using. Now, once that audio device is being launched or once that audio device is getting upgraded, you will get a Slack notification that a new firmware has been pushed or a new firmware has been released for that particular audio device. Based on that Slack message, Jenkins job will be triggered. So you can configure Jenkins webhook, which will help you to trigger your Jenkins job based on the notification or Slack message you are receiving. Once your Slack message has been sent on particular channel, the Jenkins job execution will be started. That Jenkins job will take or pull your test code which is committed in about validating of volume feature or a volume feature of your audio device for using Appium and Python library. So that will pull your test case data from GitHub. It will check out that code on the Kubernetes pod using custom Docker image. Now your execution will be started on all the devices. Let's assume that you have 2 or 3 parallel devices which are connected on one particular system. So on all 3 devices, the new firmware has been installed. Once the firmware has been installed, the test execution will be started. After the execution, let's assume that you have one test case which get failed, and for that the Jenkins job will create a Jira ticket, and for remaining and for all the 3 test cases, your Jenkins job will update the test management update the result into any test management tool. Job will also initiate the email communication about your execution, validation, and result of everything via email. So this is the example that how you can configure your end-to-end validation environment for IoT device testing. You can also consider a same example for home device system, that if you have a home security system where if someone is opening the door or opening the curtain of your home, the alarm will be triggered, and based on the alarm you will receive the notification. To automate this entire scenario, you can also do the same level of infrastructure, test case automation, and little other things. So I hope you are now able to understand that what we can consider as a future of software testing, what is going to come in as a part of embedded or IoT device testing. Let me give you another part that currently all the top industries are moving towards IoT. Let's assume that, let's consider that manufacturing industry who are now considering that manufacturing based on the stock, the manufacturing of the product should be started in the unit. Transportation, let's assume that automobile or transport industry, they are automating in a context that if you have, if you can start your car, you can start your car AC, those all can be a IoT. Healthcare industry, again, whatever, you can consider a capsule where it will give you the data of where the capsule is going inside your body via internet to server, and then you can validate that what is the health and other things about the patient. They are also using smart light, smart parking, so energy and utilities. That is being also used into the retail business where, based on customers' behavior, they are monitoring that. So that is where also agriculture is one of the highly used IoT domain. Finance domain is now also using the IoT. So I'm considering that a future of software testing is embedded or IoT testing. If you have any queries, you can post the message to QA Touch and we will surely help you to answer. I would like to thank QA Touch again for providing me this opportunity. Thank you, everyone.
Thank you, Maulik, for this webinar. Thank you for sharing your knowledge and time with all of us. And also, thank you to all the participants. Till we meet next time, keep learning, keep testing, and do not forget to follow QA Touch on our social media handles.